So the worksheet that you see here, please only do the odds, okay? Let's take a look at section number 1, which is 1 through 16. It says, find the intervals on which f is increasing or decreasing. Find the local maximum and minimum values of f. So that means if they're just dealing with increasing, decreasing, and local min and max, what derivative do we need to do for numbers 1 through 16? That's just our first derivative plus minus chart, okay? So to answer your questions for 1 through 16, I expect to see a first derivative plus minus chart, and then I expect to see the intervals. So from negative infinity to 1, it is increasing. From 1 to 6, it is decreasing, blah, 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 okay? You can check your work by throwing your function into Desmos to verify it, but the answers have been given. So 1 through 16, first derivative plus minus chart, tell me the actual intervals. Same thing for 17 and 19, okay? Now, in 20 and 23, since they are asking for where the concave function is concave up, this time we need a second derivative plus minus chart. And remember, a function is concave up, our cup is up, where our second derivative is positive. So you only have to tell me the positive portions of the plus minus chart for our second derivative. Again, please just do the odds. Now, the problem with 21 and 22, by the time you take, or 21 and 23, by the time you take the second derivative, you are going to have to look at where your numerator and your denominator are equal to 0. It is going to get complicated. You are going to have to, unfortunately, simplify it as much as you can, factor it, and stuff like that. Okay, and I'll help you if you need me to. For 24 and 20 through 26, so really just 25. Actually, for number 20 through 22, okay, so let's go back up for a minute. Odds up here are good. Okay. 17's good, 19's good. But for this 20 through 23 section, I only want to do one fraction and one. Let's do 20 and 23. Okay. Now for 24, I'm going to kind of do the same thing. Let's do 24 and 25. Now let's talk about the rules they want for 24 through 20, for 24 and 25. Find the intervals on which the function is increasing or decreasing. There you have to do the first derivative plus minus chart. That will also help us determine the local mins and maxes. This last piece, you are going to have to do the second derivative plus or minus chart to answer your questions on concavity and inflection points. Now, 27, 28 through 30, you're only going to do 27. Don't worry about the other ones. So you're only doing one of those. 31 through 35, see how it says intervals of increase and decrease, local mins and max, concavity, and then sketch the graph. And then you can check your work on like Desmos or something like that. These ones are very, very funky. I only want you to do one of them. Let's do 32. If you've already started this and done some of the other ones, so be it. I'll give you some bonus points. 35 and 36 says use a graph of f to give a rough sketch of the intervals of concavity and the points of inflections. Use a graph of the second derivative to give better estimates. Yeah, just skip that. Okay, so now that we've kind of organized what we're doing, I would like to do a funky one together. What we're going to do is I would like to do 32 with you. It's one of the most complicated ones and has the most stuff they want you to do. So at this time, we're going to do 32. Okay, so we're going to find everything. First derivative plus minus chart, second derivative plus minus chart. We're going to label everything. We are going to then make a rough sketch of what we find. Okay, so our first derivative is 1 minus x to the negative 4/3. Okay, now our original polynomial, or I'm sorry, our original function doesn't have any issues that we can't plug into a 1/3 power. We should expect no jumps, holes in the graph. So kind of keep in mind what you're working with. But this is, and if I could subtract, and nobody said a word, what is 1/3 minus 3/3, Mrs. Hunt? Anybody want to tell me? It's negative 2/3. I'm kind of a dork, sorry. So remember, we are looking for points that are undefined and also points that are equal, that function is equal to 0. So we could think of that as 1 minus 1 over x to the 2/3. The point that makes that function blow up or undefined, x cannot equal 0. So that's a critical number. But 0 does work in the original, so it is a point on the graph. So it is a point we should include. If you set this equal to 0, move the negative 1 to the other side, or move the 1 over to the other side, make it negative 1. Cross multiply. We get that x is 1. So our first derivative plus minus chart, we have to include 0 and 1. And I only need like one row because I kind of just have one thing. Okay. So let's do some test values. Let's plug in negative 1, 1/2, and 2. Okay. If I plug in negative 1, I get 1 plus 1, which is a positive. If I plug in 1/2, let me tell you what we get because I don't know. I get a negative. Throw into a calculator. It's like negative 0.587. If I plug in 2, 1 divided by anything is going to be smaller than 1. I do get a positive. Okay. So before we move on, let's analyze that first derivative chart. Okay. So if I could say it's increasing from negative infinity to 0, and then also from 1 to infinity. It is decreasing only between 0 and 1. Okay, so that means since we are increasing then decreasing, there is a local max at x equals 0. There is a local min, same logic, at x equals 1. So that is our first derivative chart, the analysis of that. Now let's do our second derivative. Our second derivative is 2/3 x to the negative 5/3. Okay. The only point that is undefined is 0, because you'd have 2/3 over or times 1 over x to the 5/3. I guess you could say it like that. So we do have to include a critical number of 0. That will never equal 0 because 2 divided by something will never equal 0. So that's the only critical number in our second derivative. So we just have that 2/3 x to the negative 5/3. So I need to plug in -1 or +1. If I plug in a negative, I would get a negative because that 5/3 power would keep it negative. So this is negative. If I plug in a positive, it's going to keep it positive. And you could plug a number into the calculator if you're unsure. So let's analyze what that told us. So it is concave down. I'll just put CD every time I write concave down. From -infinity to 0. It is concave up from 0 to infinity. So that change, that switchover happened. So we have an inflection point, which I'll put EP, or IP, I'm sorry, when x equals 0. So 0 is a local max, but it's also an inflection point. So I think what's going to happen is we're going to have like the concavity is going to be different on both sides, but it's probably a pointy point there, I think is what happens at that point. I don't know. So this is kind of what we have so far. So let's make sure, if we look at our information, we did increase and decrease in local min and max concavity, and now we're going to graph it. Okay. So I always look at a function like this, and I like to plug in the points of interest. So the only points that really came up in our calculations are 0 and 1. So I definitely want to include that in my calculations. So let's plug those values in. Okay. If you plug in 0, I think I must have done some calculations wrong, unfortunately. Guess what Mrs. Hot forgot? Oh, poopy butt. So you have to redo the whole entire problem. A little bit. Plus or minus. There's got to be a plus or minus at this spot right here, which means there's just a little mistake right here. Well, it's not a little mistake, but yeah. But let's put, it doesn't change our second derivative. Oh, that's for the first derivative. Yeah, for the first derivative, Mrs. Hot forgot to put the plus or minus when you take a square root, and there was a square there. But anyway, so if we plug in, yeah, so if we plug in -1/2 to our derivative, it's going to square it. It's going to do the same thing as +1/2. That's negative and that's positive, I believe. Let me just check my work. Increasing, decreasing, decreasing again, and then increasing. Yeah. Okay, we're good. So I found my mistake. Thank you. Oh, ooh. So let's change our intervals a little bit. 0, 1 still's doing the same thing, but -1 is so 0 was an undefined thing. There is no change from plus to minus, so we don't have a local max at 0. We have a local max at -1. Our increasing spots, yeah, let's change these ones. I'm so sorry. least I found it. Okay, so our increasing goes from negative infinity to negative 1, and then from 1 to 2. Our decreasing still goes from negative 1 to 1. I don't know if that changed things. I think it changed something. Okay. Okay, that was your first derivative that changed. Okay. So anyway, so we have to plug in 0, negative 1, and 1. If you plug in 0, you do get 0. If you plug in 1, you get negative 2. If you plug in negative 1, you get positive 2. So now we're going to graph this sucker. I know. That's why we're doing this one together. I don't know. Okay, so let's plug those points in 0, 0. At negative 1, we're up at 2. At positive 1, we're down at negative 2. Okay. Now, it is concave down from negative 1 to 0. Let's talk about the zeros for a moment. Where does it hit the x-axis? So where does our original function equal 0? So I'm going to take out a 1/3 power. That's my lowest power. And then I get 2/3 minus 3. I don't know if that helps us. And this is 0. And this is where is x to the 2/3 equal to 3. So x is the 3/2. So that's the square root of 3 cubed. Plus or minus, Mrs. Hott. Doing it again. Okay. So that is plus or minus the square root of 27. So that's roughly just a touch over 5 and negative 5. So let's put those on there. Intercepts are always helpful. 1, 2, 3, 4, 5. Just a touch over. 1, 2, 3, 4, 5. Just a touch over. Okay. So what's happening? Okay. Concave up, increasing. Concave down, increasing. Concave down to there. So that's all concave down, increasing, decreasing. Concave up, decreasing, increasing. See how the concavity changed at 0? Okay, so our graph looks something like that. Okay, so some of these can get rather complicated. As you can tell, it's easy to make a mistake. If you're taking the square root, please put a plus or minus or it will mess up your equation. How do I know it's a square root? Look at this. A 2/3 power, I have to square root it because of the 2 on top and then cube it. And that's what you have to put a plus or minus. So anyway, there is 32. So you have the rest of class, please, to work on this. You have three homework. You saw what one problem entails. So it's a lot of work. Okay, so there you go. Do your thing.